Hello, hello. Today is April 30th, 2025. This is workgroup serving weekly meeting. Welcome, everybody. As usual, we want to start with some workstream updates, if there are any. I know that this is a slow time for many people. Orchestration, anything, Jackson? Okay, nothing here. For DRA, there was a meeting, device management meeting yesterday, and generally DRA is on track for GA. I think GA is the only biggest topic that we discuss right now, biggest priority. So not much for this working group to update. Auto scaling, anybody? Okay,
I'm actually curious about the historical presence of auto scaling here. Was there a particular work stream at the beginning of serving? I
Yeah,
can give auto scaling DRA updates in general, but that might just be not super useful to this community.
it might be interesting. Historically, we started with auto scaling, and every time we discuss auto scaling, you can find some documents with separate meeting notes. Historically, also auto scaling discussions get into discussion around how fast we can pull images, because it was a biggest top of mind for everybody. So at some point it wasn't that informative anymore, because all the meetings get into this discussion of image pull speed. So maybe at some point it needs to be revived again, because I know many clouds already solve the image pooling problem, at least have some solutions. So yeah, if you have updates for DRA auto scaling, it will be very useful actually.
Yeah, well, so we've begun 133 integration work, so we're sort of following a little bit behind Kubernetes 133 release, but I think we expect to have integration with the 133 features for DRA in the next 6 weeks or so. So that's the status on that. I'd love to loop in conversations around image pulling optimizations into SIG auto scaling, because I think SIG auto scaling was kind of out of the loop when that was happening. And so if that comes up going forward, I'll definitely pay attention and make sure we have some SIG auto scaling representation there as well.
So do you expect DRA and beta and auto scaling working together soon?
Yes. Yeah, PRs are in flight right now.
This is amazing. Okay, multi-host, anybody? Okay. Yeah, we need to, as we discussed before, we need to rediscuss what would be the cadence and work streams for this meeting, because in the beginning we had all these conversations and discussions, and now it boils down to a few work streams that we actually working on, and maybe need to restart some work stream updates and understand what we do next for these work streams. Okay, sub project updates. Kellen, do you want to talk about Gateway?
Yeah. No major updates this week. We've had some pretty good discussions in our meeting, which happens tomorrow. We have the recordings online if you're curious there, but we're hoping to cut ODOT4 in a couple weeks. That should have some interesting features. So more details when that happens.
Okay, great. Sharing catalog, anything new? Okay, I see Ashok has a lot of stuff under inference perf.
Yeah, so inference perf, the following are some of the recent notable changes that went in. So we have multi-stage performance run now. So this means you can run different request rates as part of a same run. Makes it easier if you want to send burst traffic during auto scaling and so on, where you can change how the traffic changes every few time blocks. So that is now supported. And we can also run it as a job on a Kubernetes cluster. So it doesn't have to be a local run or just in a Docker container anymore. And we also added support for different API types. OpenAI chat completion and completion API, both of those with VLLM is now supported. Yeah, we are looking for some more changes to improve the latency metrics. before we can cut a release. And that is the Prometheus metric change in progress too. So yeah, those are up next.
Okay, thank you for update. Next, there is open discussions, and either Andrei or Akshay.
Yeah, I'm here. Are we ready to talk about it?
Yeah.
Yeah, sure. So I think like we just want to follow up on the discussion we had like 2 weeks ago around using leader worker set for distributed cache. Maybe just to remind everyone, I think I linked the proposal in the working observing meeting
You want to
notes.
present the screen, or
Oh yeah.
I will make you co-host first.
Yeah, give me a second. Yeah, so just for the context, just to introduce myself, my name is Andre. I work at Apple, also a member of Keyflow community. What we try to propose here, so our team have built the distributed data cache on top of Kubernetes, so folks can actually fetch some data from Iceberg tables and feed this data to the training workloads in a very efficient way using Apache Arrow, Data Fusion, and Apache Iceberg. So we already give like some sort of presentation of this topic last week, but feel free to check out this proposal on the architecture standpoint. We're right now working on the benchmarks and working on some other updates to open source it. So the discussion we have right now, it's mostly around leader worker set. So why leader worker set is important for us, because we're using the leader worker set to actually run distributed cache on top of Kubernetes. We're using this to run the head nodes and the data nodes, so the data can be distributed before the data can be fed to the GPU. So actually, do you want to add anything else before we jump to the specific questions we have from the leader worker set maintainers?
No, hi everyone. Yeah, I think as Andrea mentioned, so we've demoed this particular proposal a couple of weeks ago, and we're working on it. And we're using a leader worker set on to deploy this distributed caching on Kubernetes. And I understand that this is the first use case to use leader worker set out of serving. So I think we really like the use of leader worker set API to model distributed applications. So and yeah. Sorry, Andre.
Go ahead, actually. Go ahead.
Yeah. So specifically, we have, I think we've identified a couple of areas where we would like some support, or just to hear your feedback on how we can use leader worker set API for this particular use case. Right.
Yep.
Specific. Yeah. And so so our architecture is like we have a head node and a worker nodes, set of worker node data nodes, and so the data nodes would have the data, and the head node would actually serve traffic from the traffic from training workers to actually access the shard information, so that it can pull the shard information directly from the data nodes. So one thing I think is I see there's also some work which is being done on the gang scheduling side, where we want to schedule the cluster as a single unit and scale the cluster as a single unit. So I see there's work on that front already. In the other area,
yeah. Sorry, I'm trying back. Just to reiterate on this. So I think why gang scaling is important for this specific use case is because the training workloads, distributed training workloads, cannot pull the data from the data nodes unless all the data nodes, your worker nodes, are available, right? So for us, it's like important to make sure leader worker set can spin up the entire cache in a gang scheduling approach. Otherwise, we cannot process with the data streaming from the training nodes, from the data nodes to the training nodes, right? From CPU to GPU. This is why it's important. I know the work is going on gang scheduling, and there is an open cap, but I think this is one of the requirements for us to actually use LWS for such use cases. Yeah, good actually.
Yeah. Yeah. So that's one of the area which we are interested in, and Andre, if you scroll below.
Yep.
To the open questions.
Yep.
In general, I think we'd like to have some feedback from the community on the use of leader worker set for these kind of applications. And if anyone is aware of any usage of leader worker set outside of serving, that would also help us for our use case. And the other thing is on the readiness check. Probably, I think this is we would like to actually have the head node being ready only when all the data workers or data nodes are ready, so that head node wouldn't receive any traffic. I believe this is already addressed, but I need to actually try.
Yeah, like one of the
go ahead.
No, one of the requirements for us, to make sure that leader worker set only become ready when all the data, iceberg shards are available on inside the worker nodes, because basically, there is some time. So there is kind of a Rust backend for head node and the Rust backend for the worker nodes, and it takes some time for those for data to become available. And we only want to make sure that the training job is runs after all the shards are available on each worker node. So some of the signals we need to see how this readiness check can go from the head node, how head node can analyze the readiness check of the worker nodes from the data nodes, basically. Yeah, so this is also one of the requirements to talk about.
Do you have a requirement to flip it back to not ready if something failed?
Yeah, so if go first, actually.
Yeah, so if so the requirement is if one of the data node fails, or it's been restarting, or it's not ready, so the requirement is not for head node to stop serving the traffic, because the head node is the one which would delegate the training workers to access the data, stream the data from data nodes, and it should from the infra side, from using Kubernetes infra. I think we want to have a mechanism for head node not to serve the traffic. So right now, what we are essentially doing is to use the default restart policy to restart the entire node, so that the traffic can be served by the different head node.
Yeah, so right now we kind of solve this problem with the replicas, because if one worker goes down, the entire cluster is down because training cannot be processed. And we solve this problem with leader worker sets support multiple replicas, so we can route the traffic to a different cluster. So this is one of the idea how it actually can be solved into the one worker failure, right? Yeah, because otherwise you have to do a lot of complex logic on the client side, because what client is doing, the training job is just calling the head node to getting the information about the data nodes. Like it's sending the Apache flight, so it's sending it's using the Apache flight protocol, RPC protocol, to get information about where the data is stored on which node. But if one node goes down, we need to route the traffic to the different head node. I think on the inference side, there is the same kind of requirement, right? Or point me if I'm wrong. Like for the when you do multi-node inference, if one of the nodes goes down, do you recreate the entire cluster?
It's a little complicated sometimes, because if it's not a CPU nodes, it's likely GPU nodes that are heavily interconnected, and sometimes you just cannot replace one node, so you need to recreate the whole thing. In your case, it may be easier to replace one node because it's all CPU and like generally there is no like interconnection requirements, or at least not that strong. It
Yeah,
would be
I
nice
think
to
that makes
find
sense. Yeah.
out like some differences with typical LWS use case, which is multi-host. So in your
Makes
case,
sense.
maybe it's easier to replace one node.
Yeah,
I don't know.
Yeah,
that's true. Yeah, I agree. I think it's easy to replace one node. It's low cost. Just I think we only need the support on the head node to actually, or the leader node, the leader worker set, to not to receive any traffic. So I'm currently I'm not sure whether that's possible by default, but I'll need to check. But let us know if that's the use case. If you think that's use case to support.
Yeah,
Yeah.
I'm still trying to understand the readiness aspect of it. Is so you have the service in front of two
Yeah.
replicas, and the
That's true.
service will decide where to load balance, right?
Yeah, but
Exactly.
if one of the worker is not ready, we need to make the head node on that specific cluster, the leader node on that specific cluster, not receive any traffic. So essentially, we need to make sure that the head node is not ready in this case.
Yeah, because otherwise the clients should not call this head node, if it is not ready, and the node readiness defined by the one data node goes down, right? Because there is still kind of, so because we stream data from those nodes to the training nodes, right, from CPU to GPU, and when we do streaming, we need to make sure all training, right?
Yes.
Yeah, so I think we just need to see like what is the existing readiness check is happening on the leader worker set, and if this is something which we should improve, maybe we should propose some API changes there, right? Actually,
Yeah, I
Yeah,
don't
that's
know
true.
LWS specific for readiness of head. It must be supported. I don't know. We need to ask.
So
But
yeah,
let me
probably I'll try. Yeah.
yeah.
Go ahead.
Let me finish it with so you said one level of readiness that head needs to know about all the other nodes, but you also mentioned that streaming can start before all the data things are not ready. So if both are not ready, or like it's a bootstrap scenario, you also want to propagate this readiness state all the way to GPU nodes, right? Is it and do you want this readiness check to flip sometime? So you expect that two replicas should be good enough to never worry about scenario when both goes down.
Yeah, currently that's the case. That's the so one of the use of we're using replicas for that specific use case to have guarantee that one of the head node is always ready. Right. So the requirement is like the data, if the data node goes down, is just we need to just make sure that the corresponding leader node shouldn't receive any traffic. So that's the requirement for our use case.
Yeah, because from the client side, they only do, so it's shown in this diagram, they only do get flight info, and flight info returns the location to the data node that the worker should call to, right? So this is like, imagine this is multiple GPUs, right? And GPU needs to know like from which data node it needs to stream traffic. And the responsibility of head node just to define the endpoint to this data node, right? So the thing is like if one of the data node goes down, when the user calls get flight info, it should redirect to the available cluster, right? Which is second replica, basically. Yeah.
So just
Go ahead,
wanted to say that leader worker set does expose a condition for available that gets set to available once the whole replica is ready. And then when one of the nodes fails or is no longer working, it drops back to replica in progress. So we have like some sort of status, like we
Got it.
expose somehow, some way
I
to
see. Got it.
check that.
And so when the status of replica is replica set is in progress, so I believe this happens without setting the default restart policy, right? Like the default policy right now is to restart the entire cluster, bootstrap the entire cluster. So let's say if we don't set that specific, if we don't use the default, so we say that the leader worker set has the status as in progress if one of the node goes down. And does it mean that the head service or the DNS is updated accordingly?
So what you're asking, if instead of deleting the whole replica, you just delete one worker, and then what happens to the DNS of it?
Yeah,
once it gets recreated?
Like you mentioned, once the leader worker set status is moved to in progress, does the DNS entries get removed?
Yeah, the DNS should still be accurate because it's linked to the headless service. The user of the headless service exposes the DNS.
Yeah, and the headless service would still have the IPs of the workers.
Yeah. So if you don't recreate the whole replica, but instead only do like the worker pod for, it would create a new one and then link it back to the headless service again. So it will have the new IP address.
I see. But the head node would also the IP of the head node wouldn't change in that case, right?
No, shouldn't.
Makes sense. Yeah, probably we'll
I
experiment
think we
with
should
that.
try it. Edwin, can you please, do you have any docs on it, so just everything on API, like to try this out?
Like everything that the API has.
Yeah, like like for us to try this out to see like how the redirection will work, right? For this readiness check of putting a leader worker set in progress.
Sure. I mean, you can look at the website. The website has like what
Yeah.
the API has.
Okay.
Sure. Yeah, I'll take a look. Yeah. Thanks, Edwin.
And also wanted to point out that the gang scheduling cap in reality is creating the concept of a pod group inside of the leader worker set, but it doesn't actually implement gang scheduling. It takes on a dependency of a custom scheduler.
Makes sense. Yeah.
So we need whether co-scheduling plugins or we need any other scheduler which supports gang scheduling, right? You need Unicorn, Volcano, right?
Yeah, exactly. There's I
But-
think an upstream proposal for gang scheduling, but that's not on the leader worker side.
I see.
Right.
And but by default, like, do you like which kind of scheduling plugins you're going to support? Because I know, for example, Volcano uses different CRD for pod group creation, right?
Yeah. So default, we don't support like anything. We expect the maintainers of the respective custom schedulers to implement their new their scheduler in leader worker set side.
So okay, so it'd be some sort of plugin, right, mechanism that you need to update the leader workers as a controller, right, to generate to create those pod groups. Okay.
We're essentially taking the dependency of custom schedulers and so that people can contribute.
And first implement, is there any? So I know there is a working cap, but first implementation, are we going to support just co-scheduling plugins or what? Or you just good.
First implementation is gonna be Volcano because that's the initial that like the person who's working on the cap is a Volcano maintainer, so that's gonna be the first one.
Okay. Yeah, I think that makes sense. I understand there is a requirement for you to have a scheduler, right? To run this any workload with gang scheduling, right? You have the same problems in in other workloads, right? Yeah, but I think like it's I guess it's even for inference it will be useful. So definitely let's take a look on this. All right. Any other maybe questions or maybe discussions you want to have?
Yeah, the only comment is it was nice presentation, and if you can keep us posted on progress, it will be nice. Very helpful.
Yeah, I think. Yeah, absolutely. Yeah, good actually.
No, yeah, definitely. Yeah, no, we'll keep you posted, and yeah, thanks for all the insights.
Yeah, I think we're doing some sort of benchmarks right now to compare, with other solutions and also to compare, with existing streaming, using just Hugging Face streamer, iterable dataset, for example, or using this cache solution, right? So we just try to also, again, right now the cache is kind of tied to the life cycle of trying job. But in the long term, we kind of planning to also integrate with, with hyperparameter optimization, because cache might be useful for different purposes during your ML workload, in your ML workloads, right? And even like considering maybe creating the controller to orchestrate those cache services also might be useful for the long term. Yeah, but happy to once we have some more kind of concrete demos or details, maybe share with this group, especially on leader workers and integrations.
Yeah, just for my curiosity, like how big is this LWS cluster? Like how many nodes there?
Yeah.
Like
so
in a picture, it's like 3, right?
No, yeah. So it depends on the dataset size. So we are actually sharding the entire dataset. So if the dataset is right now, so that's one thing because the cluster the size of the cluster is actually provided as an input from the user. So we want to actually make it auto by using the size of the dataset. But so we are still figuring out how to address that use case. But right now it depends on the dataset. So if it's we tried with 10 nodes as well. So it really depends on how we want to, how many what is the topology of your training workers, and how we want to use shard the dataset across the workers in distributed training.
Yeah, right now we kind of ask users to define the cluster size. For the long term, we're planning to automatically kind of define an algorithm who will decide what should be the cluster size. Optimal cluster size depends on resources and availability, right?
Are you talking about single digits, double digits, like triple digits?
No, it's like, again, for 10 nodes. So the things I think actually pointing from it, we tested, for 5 GB of iceberg tables, like 5 GB of data, right?
4 gig. Yeah, 4 gig.
Mhm.
For 4 gig, we used like 10 nodes.
10 nodes.
Okay, makes sense. Thank you. Yeah. Any other questions? Any other topics for today? Going once, going twice. Thank you very much for everybody who came today. It was a good meeting. Bye.
Thanks, everyone. Speak to you soon.
Thank you.